Anyway, so I used it a lot. Okay, so that's yellow.
Yellow.
So I'm going to match up the 9 and the 5. So the 9 is right there, and is right on that side, which is the 5. So this is relatively matched up. So I'm going to push this in until I get resistance, and I'm going to let it...
Here have the resistance from here and put it inside.
Okay, and then I'll wait 3 minutes.
Yeah, wait just 3 minutes.
Okay.
Good.
Shoot.
And after that, select the holder.
I'm sorry?
Select the spaceman holder.
Okay. Single
So
tilt.
it is.
Okay.
And you can
And
see
then
there,
the
the
turbo
time
should be
starts
right
counting.
there. Okay.
This is a very powerful tool, especially when you know what it can do. And most users in that they only simplified their function. We didn't use much function there.
Really?
Yeah.
I would love to do wheels mapping, and I would love to do HRT running. So I hope
More
that's...
than that.
More than that?
This
Okay.
one has more than I still play with the functions.
Because I have, I don't know,
Now I'm playing with the holography.
what's the holography?
It's the biplanar.
Oh, okay.
That can be played.
I could do topography, that would be interesting. Or tomography, yeah.
Tomography, yeah.
That would be interesting.
I can teach you. I
That-
can teach you.
That's pretty
I
complicated.
spent almost a year on that.
Oh my gosh.
Because I need all the process, especially software related.
I want to be finished in a year and a half. I don't think I'm going to do that then.
This, tell you the truth, when I really have some feeling of this, I spend like 5 years.
Really?
The whole my PhD thesis time working on the application of this kind of stuff.
Wow.
And my major work every day is TM.
It must be cool to be so specialized in one instrument. Because for me, I'm split between material science, just studying my materials, but I'm also in chemical engineering, so I'm mainly doing the application of those materials. So I spend half my time figuring out how to make them, analyze them, and then the other half,
Too many things to handle, need to handle.
I don't feel specialized in one thing, I just kind of feel broad. Which is okay, but
Time is limited.
yeah. I don't know, some people stay here for 7 years, so, but I don't,
For the thesis,
yeah, but I don't want to do that.
normally the material science, 5 years.
Yeah, that's alright.
5 years.
Some people in chemical engineering do it in 4,
Some even
4.5, yeah.
even 4, because if you have a master degree already,
Yeah.
then 4 years will be enough. Then you can go to the postdoc, get more training. That will be different training.
I don't know. if
Especially you switch the group.
Yeah.
Do not keep in the same group.
Yeah. Where did you do your PhD?
PhD in China.
Okay. And then did you do a postdoc before you came here?
I'm working in Germany for a year.
Oh, really?
Yeah.
Where in Germany?
Munich
Okay.
and Aachen
I don't know where that is.
and
This is funny.
Cologne.
I really want to go to Germany after I graduate. I'm actually
Very
starting.
nice. Very
I,
nice.
when were you there? What time? What year?
2003.
Okay, so
2002 to 2003.
okay.
10 years ago.
So did you learn German?
Now, only several words.
Okay.
Guten Morgen.
Yeah.
Guten Morgen.
It's so hard. I'm trying to learn that language now. It's a pain.
You build the environment.
Oh what?
Build the environment.
Yeah.
That
Or-
will be much needed.
Or a German girlfriend.
That's shortcut.
That's what everyone tells me. Okay, so it's done.
Get it back. Get it
And then,
back.
and then slowly let it go in. Then push. Okay. Phew. And then turn the turbo off.
Turbo off.
Okay.
And you can close the working overview panel. Close that.
Just X?
Yes, yes.
Okay. And then
And you can open the column bar.
else?
Then you will see the beam. Yeah.
Okay.
And then you can have a six. Move the cover away, the screen cover. And also you can cover the sample holder.
Okay.
Yeah. That will be good for your resolution work. This cover have two functions. The first function, the isolate the acoustics wave
Okay.
to the holder, and
And
another
explain
keep
the
the,
shape.
the temperature even.
Okay. And so, do I just go like this?
Yeah.
There we go. Okay.
Not much German people here around.
Really?
Not much. Do you have a lot here?
Here, yeah. But they mainly come to do a master's.
Ah.
I know one person that's, I think, a postdoc in chemistry.
So, and I can quickly show you some how to do the EDS.
Okay.
So first, know the map because the high map is not easy to see the beam, right? Now you know you can see the current here. So that means the beam is here, just blocked somewhere. I see, blocked by the grid.
Yep.
And then spread it out, and reset eccentric focus.
Okay.
Put it eccentric for every time and reset to default the
Okay.
objective current.
Okay.
Then you can see your focus is not away, right? Then we need to find your sample. The same sample?
No, it's a different sample.
Oh.
I prepared this one.
And you can see you can
So
move
hopefully
low
that would
mag,
be-
low mag. You can see the speed is also linked with magnification.
Okay.
In the low magnification, your moving will be faster,
Okay.
and the high mag moving will be slower.
And I can also adjust it with that plus and minus.
Plus and
Yep.
minus. Mhm.
I prepared this one a lot lighter, so hopefully there's not as much sample.
Not much.
Hopefully there is some sample though.
Not much. At least in several holes, I didn't see samples. Something like here, you
Might have
get
to-
the sample. And when you change the samples, when you want to find the sample at the beginning, normally you a little bit away from the focus, because if you add the right focus,
Yeah, you have minimum contrast.
minimum contrast is so difficult to see the sun. This is your sample? Do you
Mhm.
think so?
Yeah, it looks like it.
Because your sample, the contrast is so weak, right?
Mhm.
So that we can using the stand
Mhm.
to check whether you have the particle in it.
Okay.
Because in this the contrast too low.
Yeah.
Right. So how can we do that? Remember low aperture in right to the stand. So go to the stand and click the stand. It will be switched to the T diffraction mode.
Okay.
This is diffraction mode,
Mhm.
and this is the CT. And you keep eye. When I click the search, the detector will be inserted. The annular
Sorry,
detector.
where am I clicking search?
The search you can see something in
But where did you click it? I'm sorry.
here.
Oh yeah, got it.
Search.
Okay.
And then you have a detector inserted
Okay.
around it. You can see it actually. Can you see the aperture, the circle around?
Mhm.
See, surrounded. This is a detector is this side, hollow inside in the center.
Mhm.
The detector, so that the amount is passing here. I see, and this is the diffraction mode. Actually, you can see diffraction mode.
Mhm.
And if you go to the image mode, you will see scanning.
Yep.
Scanning. But I don't know how can do adjust it because at this time you can see the beam. If I stop searching, beam like this,
Mhm.
right? But actually, what we want to search in is that beam is one fine spot,
Okay.
right? So we focus the beam, and you can screen increase the. I need to ask them to how to adjust this one, and you can make it smallest,
Okay.
because the resolution is decided by the spot size,
Okay. Yep.
right? So then we can go back to diffraction mode. The detector in. Did you see the detector?
No, I missed it.
No. Let's see. Let me put this one out. You will see. Did you see the aperture out? And you can
Sorry.
see aperture in.
Yep.
See the aperture?
Okay. Yeah. I see that.
Then we search it. Now we just a little bit of focus, you will see, oh, wrong way. The spot, the focus depth is too big.
Okay.
Much clear, right? Much clear. And seams have some stigmation. Let's focus increase a little bit and do some stigmation change. Stigmation is we change we stop the beam. Stop beam.
Mm-hmm.
And then do you remember I showed you that the Rochgram?
Yes.
Rochgram in the central beam, and you change the focus, you will see like the basketball something inside. Actually, that is the magnification, the largest magnification, because in the central spot actually is a bright field image.
Okay.
And you change the focus, that means the image will be zooming,
Mm-hmm.
and to infinity. This is do you some seem to have a little bit of contamination?
That's not good.
Contamination.
It's a bad sample. I can always put the other one in.
Yeah, no, the contamination, and I can show you how to treat it. We have the plasma cleaner to treat it. Not too far. Then search it. This is the contamination. Why is it brighter? Because when I focus the beam there, then there's some carbon it will absorb there,
Mm-hmm.
and build up. Then you have this dark. And this is the spot I just passing through.
Mm.
So this when I focus the beam, contamination build up.
Okay.
So that if you want to get a high resolution samples, and this one you have to be avoided,
Okay.
especially in the STEM mode.
Okay.
And later, I'll show you how to using our plasma cleaner to treat your sample.
Okay.
To burn the organic things away.
Wow. But my sample is actually organic. It's carbon.
Carbon should be short-term treatment.
Okay.
Short-term treatment.
Okay.
But there something, and you grade seems something is not clean. Otherwise,
Okay.
you can see it's on the, yeah, that's why it cannot be clean. Cannot be focused very well. The sample is
Okay.
dirt.
Do you want me to put a different sample in?
If you have another one,
Yeah,
maybe
yeah.
you can try another
I
one.
can use the same one from last time.
Yeah. This is, you can see that this is too serious. Stop. And then we can change the sample. We go back to the image mode, the TM mode.
Okay.
And I give it to you to do it, to change the sample. And first,
So first you gotta close the column bellows.
yeah,
So we'll close that. Then.
search, reset the holder,
Oh yes.
and that's the key.
Is that holder? Yeah, because that is way off.
Yeah. With the red light off, you can see here have a red light. It's moving away. Moves this one away.
Okay.
Here but light.
Okay.
Even the red do not move.
Because it's still moving inside?
Sometimes it's not ready to take the sample out.
Okay.
So that's there. If that's red, if that is red, do not touch the holder. Now it's okay, right?
Okay.
Yeah, take
So
it out.
no red, take it out, then turn the turbo on as soon as
Yeah.
possible.
Yeah, now you didn't trigger on the turbo, right?
Nope.
Yeah, this is normal.
Okay.
If you want to do the plasma cleaner, we need half an hour earlier to turn on the plasma cleaner to warm up.
Okay. Where's Where's the press continue with
In
it?
another room, I will show you.
Still orange. Yeah, I traveled to Berlin, Munich, Hamburg, Bremen, and Freiburg. I saw all the outside cities.
You visit more cities than me.
Really? Oh, no. I've been twice.
Because I didn't travel a lot. I just stayed in a small town.
Oh, really?
At a small town. Only the 30,000 or 30,000
Really?
people.
And there's a
Very small.
university there?
Not a university, a research institute.
Okay.
It's a big research
Oh,
institute
okay.
in the Europe,
Okay.
in the forest.
This is kind of like CERN, I think, because I think CERN's in the middle of nowhere too. It's somewhere in Switzerland, but it's just a small town. There's nothing around it at all.
Because we have a long history compared to the US.
Yeah. I just love, like, you go around and like all the small houses, the architecture. It just looks so
Beautiful.
Yeah, I know.
It's beautiful. Not made by wood.
What? Oh.
Not made by wood.
Yeah.
The US.
Yeah.
You have several centuries.
It's
If
so
not
weird.
bombed in the Second World War.
Yeah.
If not in the Second World
A
War,
lot got destroyed there, yeah.
Yeah, that's so you can see that it is a long history sense.
It's so weird because you go to some of the churches and it was like, this church, they started building it in 977 and then they finished in like 1050. It took them 70 years to build this church. But
And to tell you a story that when I first come here, when I on my way to my institute and I have a house that built up. When I left, it's still not finished yet.
really?
I really only 2 guys
Wow.
to work on it.
Okay.
But this is all bricks. You know, another other earth things.
That's so weird.
Yeah, but this is high quality.
Even in 2000.
Definitely high
really?
quality. You know that in the basement, outside really, you sample and then you close the inside will be dry. High quality, definitely high quality. They all have basement. All the house have basement because from the Second World War we have the
Yeah.
family. Everybody have the basement. That's safety place. With the camera.
Oh, I'm sorry. I
Yeah.
have no idea why I took that off. Okay.
Have more practice.
Yeah. Okay.
No, wipe it off.
I don't know. That's a good question. Ugh.
Think too much. You have to wait another 3 minutes to turn it on when you put it in.
Let me put this back in the center. This way I won't forget to cover this time.
Yeah.
And
I have the feeling that after you make one mistake and next time when you face, you always reverse.
what?
When you make the mistake,
Yeah.
when you second time with the same situation, you always reverse.
I know. There's some study that shows that when you're trying to memorize something and when you have like adrenaline, so like when you're when you have fear or when you are really stressed, you always remember it the next time. I think it's the same concept.
This one only when oh yeah, you can take it out. Only when it fully stop, then you can restart it. This turbo pump, you know how large the turbo pump is?
I'm sorry?
Do you know how large the turbo pump is?
How large?
Not the big one, not the back side. Actually, the turbo pump is located here.
Really?
Yeah, that is just the mechanical pump, the pumping the pre-pump. Just the inside, 120. You know, this side.
Really?
Just this side. Last year we have some, this one have something damaged inside, so that we replace this one. Then
How much
I
is it?
know how much it is.
How much does it cost to replace?
Because we have a service contract,
Oh, okay.
it's covered. And if not, it is around like 20,000.
Because we have two turbo pumps that we have two gas absorption type of things. We do like pressure isotherms. So we have two of those for activating samples.
Okay. Good.
Okay.
Save you a lot of time because it's warm.
So line up the pins and then push them tight. Okay.
Good.
Oof.
Select the holder. You didn't select it, the red line is always on.
Oh, that was it.
Yes.
Okay.
It's much easier to operate. But you have to know the fundamental things, otherwise you don't know how to adjust and manage things. You need to know the fundamental idea inside.
Just wondering, why is X at negative 2.25?
That's, you know that when you put the sample folder in or take it out, you know that you have to move in a little bit.
Okay.
Then it's have a little bit away from the zero. It's normal.
Okay.
The key thing is the tilt, alpha, beta, AB. That should be not change. Especially when you do the ES. We need to tilt the holder 50 degree. And then somewhere is here. So we tilt the 50 degree detectors here to make it a faster detector, increase the efficiency.
smooth.
How about now? 看看周线。
Okay. Turn off the turbo.
Now is the right time. Then the column off. Yeah. Cover.
Okay.
Good. Yeah, now we have the beam. Good. Now the mat, spread the beam. Here's the one have a sample here. Let's switch around. Always go faster. You can. Oh, there's a lot of sample here. Reset the. Minimum contrast. So minimum. Yeah. And today I'll show you how to do the EDS, right?
Mm-hmm.
And then we need to tilt it alpha 15 degree.
Okay.
And and move it like this. How to tilt it, you can see.
Mm-hmm.
50 degree, you can read from there. Positive.
Yeah. See.
Positive. So this side, because it detect there, you tilt it.
Mm-hmm.
Sample face. 15 degree around. So. And when you're at the right height, eccentric height,
Mhm.
you tilt the sample actually didn't change much, right?
Okay.
Because this is the
Yep.
eccentric height. So sample here, and if you want to do the EDS, you can do in the TM mode or
Okay.
in the STEM mode.
Okay.
STEM mode have a much better spatial resolution
Okay.
because the spot size is very tiny
Okay.
in the STEM mode. So let's go back to the STEM mode to do the use to see, and then in the STEM. Let's see the beam. It's only default. Need to change it. Why we always need to do
Focus the beam.
body flash without that section?
Mm-hmm. It kind of looks a little thick to me. I don't know if it looks thick to you too.
Small sound is there too big. And we can go to the amorphous area to do some stimulation adjustment. This is the carbon, right?
Mm-hmm.
And then this beam spot stopped in here. But you also can use this to move the beam as you want it.
Okay.
And then you can see the in the image mode.
So just that purple with the red of the purple crosshairs.
Yeah.
These-
And you can see the beam, you can see I'm moving.
Okay.
You see I'm moving?
But which one is it? There's two crosses. There's a red one and then there's one right below
Yeah,
it.
together.
Okay. Oh, I mean on the menu. There's that.
This one.
This one. Okay, the one with the circle. Okay. Image
This
position.
is the position. This is the what's this one? Beam position.
Okay.
Beam position. And you can see moving. That's nice, right?
Yeah.
Diffraction. Then let's check the stigmation to see the rush grain. And you can see from here, right? Our eyesight may be different.
I see it in the center.
Yeah, but the image is not the right circle. You need to do the stigmation.
Okay.
The objective stigmation. Where it is. See. The condenser stigmation.
Condenser stigmation, right where the vacuum control is. Okay.
It will be automatically show. It will disappear.
Oh, perfect. When you hit the button. Okay.
So then we go back to the image. The focus image seems looks better, a little bit better, right? Then go to the sample. This area have some particles,
Okay.
right?
Yeah, that looks fine.
Blurred. Blurred again. Then we can using the focus. Moving somewhere. See.
So the focus button on the left.
Yeah. Still a little bit not clear. Spot side 9, spot side 9, that's nice, that's good. And sometimes we use the Gangnam's 5. Gangnam's.
Okay.
Gangnam's 5, but there, I think that's there. We didn't, should be fine at the moment. Still should be fine. Because we didn't see want to see the higher resolution.
Mm-hmm.
The stem atoms. Right, we just want to get some other.
I really just wanted to map out the
relationship.
particles, yeah.
Right. So let's check this combination whether this is iron or not.
Yeah,
Right.
that's pretty
This
much
is
all I
the-
wanted to see.
Yeah. So this particle definitely should be the iron.
Okay.
Let's take a look. And if you want to acquire,
Okay.
you just acquire, click it. Acquire. During acquire, the scanning speed a little bit high, give you little bit lower, give you a much better quality image.
Yep, I'm seeing it. I'm really hoping the smaller particles are iron too.
Yeah, this image, and you can save it. Right click, export data. Yeah, the good is go to your folder.
Cool.
And remember to select the weight scale marker.
Let's, yep.
And the same thing, right? You
Yeah,
touch
just
the-
-4 is fine.
Oh, do we return it's saved? Then we go to the analysis. Do you remember I have this folder for you, right? Analysis. And we also go back to check whether the sample is moved. You see sample moved.
Yeah, it's moved a little bit.
Because why? Because the sample we put it inside and it's not stable.
Mhm.
It needs some time to make the temperature even.
Okay.
Right. So that's the way in the in this preview and mode, and then we can go here, come here, EDS.
Mhm.
Then you need to you want to view the EDS. That means you can see this is a flashing. That means the detector, the shutter is closed.
Mhm.
When you open the shutter, then you will see the signal.
Where did detector control come from?
It automatically come out.
It automatically comes
If
up,
not come
okay.
out, you can come from here.
Options, okay.
Inca.
Yeah, Inca.
Option detector,
Detector control, okay.
And this is the location where the signal
Okay.
comes from. You can put it here. No. Why? Stand.
Yeah.
And 6.
How long does it take for a sample to stabilize? Like around?
Half an hour.
Oh, jeez.
Or
Okay.
an hour. Sometimes if you want to do high quality image, you
Yeah.
overnight something.
Wow.
You can put it in that negative stable for overnight.
Okay.
And you can see this one, and then we can acquire, because the view is the spectrum only in the several seconds,
Mm-hmm.
2 seconds, but the acquire is longer, and it seems like sample moving again.
What dead time am I aiming for? Am I aiming for the same as the SEM, something around 10 or 15?
Yeah, and below 30. From my
Below 30, okay.
from my experience, below 30. And we put it here, we directly acquire it. Acquire. And see something, right?
Mm-hmm.
Then you can see here, EDS content set up, and this is the big identification. You click it.
Okay, the second one.
Yeah.
Silicon.
Definitely have silicon, right? A lot of silicon.
No, it shouldn't have silicon.
No silicon?
No, it shouldn't. That's strange. It should be an iron particle.
No. The matrix.
Hmm.
The matrix,
Oh, yes, yes.
right? And you have the iron.
No, wait. I mean, it should be iron on carbon. There should be no silicon, as far as I know.
This is one strong silicon.
That's very odd.
Yeah, you need to pay attention. We have the on the substrate or something. Where the silicon, the silicon is very strong,
Hmm.
and it's finished. No, there's a time remaining.
Okay.
But I think that there's a sample drift. So this one I can save it for you, and you can export. Export. This one is what is a BMP, means image.
Okay.
Image. But also you can click here. You can see at this time what we clicked is you can see this the box is selected. You see,
Mm.
and then you can click the curve. This start point and this end point. You see.
Mm-hmm.
And then you export is export is a 2-column text.
Oh, okay. So you actually
You
get
can
the...
draw it by yourself.
Okay, good.
It's nice, right? So then we go back to check the sample. Definitely go away.
Yeah. So odd. Where would silicon be coming
Yeah.
from?
And then we can see some background. So what this background is, is that the silicon dioxide or something?
It shouldn't be.
No.
Yeah, it should just be carbon, maybe some
Just
oxygen.
carbon. So this particle is mostly silicon dominated.
I have no idea where silicon would be coming from. I'm starting with an iron carbide. Unless there's an impurity in my...
This major is you can see this area is no silicon.
Yeah, that's very interesting.
Yeah, this is no silicon, and this particle is silicon. If it's iron, the contrast should be much higher.
Hmm. Okay. Interesting.
Yeah, silicon, silicon iron,
I'm sorry?
silicon and iron.
I don't know
But
what's-
the silicon is more silicon.
Interesting.
Then this is why this is very useful for you to go back to check your procedure.
Yeah. Do you mind if we try another particle?
Yeah. So you can see this is the true, right? You can stop it. You can stop it, and you can save this one. Then also you can save this image to see where the sample located, and then you can see and the screen overview. Let's see, you can see whiskey marker and screen resolution. Screen resolution tape. And they are giving this one, this curve, it's plotted 2-column, this contour, right?
Mm-hmm.
And this image, it's plot image, point 2. Okay, so let's go back to search. Right, we find another location.
Mm-hmm.
Yeah, you can see the contrast of these two. Definitely, now it's reasonable because they're silicon and carbon the atomic ratio, atomic
It's a lot.
difference is not as
Yeah,
much as
as
iron.
iron.
This one.
Yep.
Yeah, okay. Let's check here. View, and we put this one